Okay, so we have our spread set up here, and we can see that working in our scene. Let me just quickly play here and show you it's working. But there's a couple of things it's not doing. It's not taking into account the actual particles igniting the stick itself. It's just looking at, is an area hot? So this is spreading both directions equally. If I move this somewhere up along the particle system, you'll see, and hit play, it's going to spread both directions equally. But that's not actually right. It doesn't look natural, it doesn't look right. So how do we make this spread more like actual fire? Well, we have to take into account the particles. So what I'm going to do is just move this back down and want it to spread more up and down whenever it catches fire. So instead of using the get neighbors and all these nodes here, we're going to change this around and get rid of all these. So we just create it because this is one way of doing the spread, and of course there's lots of different ways of creating effects inside of eyes. So it deletes a bunch of those nodes. I've left the burn and the add and the clamp. Just going to reconnect some of these back up. The clamp here and the clamp into there. And we're going to use a closest point. So what closest point does, get closest point, we'll look at some geometry, in this case our particle cloud, that we're going to bring in right now. So get the point cloud in, and point clouds are geometry just as any other object is. And then we're going to get the point position. Those are all the points on the object itself. So it is a self point position. And then we're going to use those to get some information we can use to increase the value here. And this is a point output, and we're going to get data. And the data we're going to use is age and age limit. So this is how long the particles will live for, and how old the particles are currently. And that's a good two numbers to use because we can get a percentage of their age, and then use the age as a 0 to 1 value if you get percentage by dividing these two numbers together. Just going to link these in. The first get data, we're going to explore, and you see it's point cloud, it's not the stick, because this is taken from closest point, actually looking at the particle cloud, the geometry fed in. And this one here, again, explore, point cloud, age limit. We're going to do a divide by scalar. Make sure that your numbers going in to divide by is a non-zero value. So age will go into value, age limit. Of course, if your age limit was 0, your particles would never come out, so that would be fine. It should always be a non-zero value. Okay, so what we have here, just going to move these nodes out a bit, just so it's less cramped in here. We're going to take this divide by scalar, that's the current age of the particles at the closest point, into the add, and it's not going to connect. It says, hey, I want an array of scalar, or I want a scalar, not an array of scalar. So I need to change this, so I'm going to get an array average. Get array average, and now I give my average per point. That's really what I want because it's giving me multiple points here. And feed this one in to the add. And this should work. Just feeding all these together, what's happening is, it's looking at the cutoff distance, it's set to 1. And if I hit play, the particles emit, and they spread up. And you can see them spread. It may spread too fast or too slow. You may want to adjust it, how they spread. And then, of course, if you move the null up, they should go more in the direction of the particles burning. So if I hit play now, they're going to spread up and down, but they're going to spread more up than they do down, because there's more particles above, so there's more closest points up here, and you can see they're going up much faster than they're going down. They are working their way down slowly as well. That again would happen if there were some hot points around here that slowly burn in both directions. So I'm pretty happy with that, but I want to have more control. Because I don't know, some of them is happening fast, some of it's happening slow. So the best way to control this a little bit better is stick a multiply node in as well. Just give me another level of control. And this is making your effects more art directable. Let's do a multiply by scalar. Just drag it in between those two onto the line. And now I have a small multiplier we can use to control how quickly the values increase or decrease. So you can see here, if it's burning too fast, I can use my multiply by scalar node, and I can decrease this down to make it slower to increase, or I can increase this number. I just go something crazy here, and they're going to get up to temperature much quicker, so that will increase. Another way to control the spread, we'll just leave this back at 1, is to go in and use the closest points and increase the cutoff distance. That's how far it's looking. So right now, we can see there, if I increase the cutoff distance, it's going to spread much faster and look much further. And if you decrease this, I hit play again, it's going to go much slower because it's looking at just fewer points. It also runs faster if you've got a smaller cutoff distance. It'll actually run faster as well. You can see now it's just looking at using the particles and the age to actually allow the spread to happen. So I'm pretty happy with this. Also allows some cool effects. So if I hit play again and were to rotate this stick, it will catch faster if I can control my rotation here. If things are burning through, let me just stop that and undo it. I'll just rotate it sideways and just show you exactly how it works. If I rotate it round so the particles are close to these other ones, it's going to ignite that area much quicker. So it's actually reacting to the rotation and position of our object. So this is working well. I'm happy with it. I have a multiplier that controls it. I'm using now closest point instead of the get neighbors. It's a slightly faster node in some respects, especially because I've got the cutoff so I can look at fewer points. And we've got the age divided by the age limit. It gives us a 0 to 1 number. We can see that number if you want to visualize it. Show values, always good to look at these. Now those numbers are going to be on the particles, as you can see, and you can see those numbers are starting at 1 and they're getting smaller the further they go away. Imagining the particles are going to be hottest, closest when they emit. That's not entirely right, but that's what I consider artist physics. That is what I think will look right is right, even if it's not entirely right. So that's the next step, and then we're going to go through next and test this out, see if everything's working correctly, and if it isn't, we're going to fix some problems. And then last of all, we're going to go ahead and make this into a series of compounds that we can use to package this up as a single tool.